Okay, this video is asking a question. Is T. Campbell wrong about plant protein? Now, first of all, I'm kind of kidding around because T. Campbell wrote the great book, China Study, and he is considered one of the world's greatest, if not the world's greatest expert on the effect of dietary protein with regard to cancer. And so his best book here, he's written a bunch of books. I think his best one is China Study, about the relationship between dietary protein and cancer. And I'll just abbreviate his name, TCC. Crap. I had this poster here, like of Irish Castle, which I thought was kind of nice. I was trying to have a nicer background, but it's falling over, obviously, so I'll have to forget that one. I got kicked. I got kicked out of my my usual room for making videos because someone else wanted that room. That's about how much clout I have in my family. So anyways, getting back to this China Study book, he fed 5% casein and 20% casein to rodents in group 1 and group 2. So group 1 had aflatoxin, which is a carcinogenic chemical from mold in moldy peanut butter, and he also fed them that in group 2 rodents that had hepatitis B virus, which is a virus that tends to cause cirrhosis over time and then liver cancer quite often. And the point was that all 20% of the rodents, all 20% casein fed rodents got cancer. Virtually almost zero of the ones fed 5% protein got cancer. So the amount of dietary protein enabled TCC to either turn cancer on and off in these rodents with regard to liver cancer. And that's pretty amazing stuff. Okay, TCC said that animal protein in general, casein in particular, the milk protein, was the worst carcinogen in the world by far. He said that it's much more important to worry about tumor promoters. Cancer has 3 phases. Number 1, initiation, like damage to DNA. Number 2, something that makes it grow. And the damage to DNA could be something that removes the regulators of growth or activates the stimulators of growth. And then promotion is something that makes the cancer grow. And then invasion, the last sort of phase, metastases, spreads all over the place, kills the patient. All right. So kind of the point T. Campbell's making is that most of the focus is on things that cause mutations. But what he's saying is that it's even more important to focus on things that promote cancer growth. And animal protein is the greatest promoter of cancer growth because it has an anabolic effect to make cells divide, and that appears to be the main cancer promoter in all the research experience of T. Campbell. Now, there's another school of thought about the Warburg effect being primarily an initiator of cancer, ischemia, lack of oxygen, hypoxia, causing the cell to not be able to run oxidative phosphorylation in the mitochondria and therefore shifting to anaerobic growth. A lot of the cells just die when they're hypoxic, but they'll shift, some of them will shift to anaerobic growth and become like an anaerobic bacteria and just burning glucose anaerobically, meaning without oxygen. Okay, but what am I getting at? Why am I saying, is TCC wrong? Okay, we're going to get right to it here, and it's an important point. TCC, one last word about his other experience. He did do experiments where he fed 20% soy protein to the rodents, and they did not grow cancers. Soy protein and other beans, legumes, are low in methionine. The cancer needed methionine to grow. That's why I gave previous lectures on methionine restriction. Okay, then he fed the cancers 20% gluten, a gluten protein, like a wheat protein, and that's low in lysine. Cancers did not grow. Okay, so the cancers need methionine and lysine to grow. And when these are diminished in their diets, in his research, they stop growing in rodents. All right, that's fascinating. Another topic TCC points out is all this talk about high quality protein, which he says is a bogus definition. And that was defined based on how fast the protein can make an animal grow. Like, let's say, how fast could a protein make a mouse grow? With the idea of, how do you feed poor people so they get enough protein and they'll grow normally? All right. But what TCC said is that's a bogus definition, because if you go by that definition, what you're basically saying is how similar is the dietary protein to the proteins in the animal's body itself, let's say in a human. And if you're going to define it that way, then cannibalism would be the best protein, which is a ridiculous, stupid, crazy thing to say. And he would say, well, then should horses eat other horses? No, horses eat grass. Okay, that's what works for a horse. All right, so TCC says that if an amino acid is missing in a plant food, that the animal can get that amino acid by eating a different plant food. And so the obvious thing is beans are low in methionine, grains are low in lysine. So if you eat both, the grains having more methionine might compensate for the beans being low in methionine. The beans having more lysine might compensate for the grains being low in lysine. And if you eat both, you get enough methionine and lysine. And the other thing, though, you got to remember is what about the absolute amounts of protein? There's hardly any protein in rice and sweet potatoes. Rice is 5% protein. Sweet potatoes is about 4.5% protein. And there's populations. Papua New Guinea got over 90% of their calories from sweet potatoes. The old-time Okinawans, back when they used to be healthy, they got most of their calories from sweet potatoes. All right. So now, do you see where I'm going with this? He's basically saying is, well, animal proteins might be missing a few amino acids, but when you eat a variety of these, plant foods might be missing a few amino acids, but when you eat a variety of plant foods, they give you enough amino acids, the animal grows just fine. Okay, well, that raises the question. If they're getting all the amino acids they could want by a combination of plant foods, are they not also obtaining all the amino acids that cancer needs to grow? And so now you're back to a second question. Is it simply the ratio of amino acids, or is it the total amount of protein? And I don't think that's been completely resolved. And it gets me back to the work of James R. Mitchell, PhD, the guy from Harvard. And he said the main thing that causes increased longevity isn't just caloric restriction. It's also protein restriction. And Kempner seemed to have extraordinary results in a multitude of ways by lowering dietary protein down to about 4.5% by rice and fruits. Okay, so I'm actually going to try to get T. Campbell to answer this question because I want to see what he has to say about it. And how does this relate to our own personal dietary choices? Well, what it's saying is, do we want to potentially, I know beans get tons of praise and they're associated with longevity in multiple studies. The Blue Zones researcher, Dan Buettner, loves them, and I've heard plenty of other good things about beans. But I wonder, how much beans should we eat? And then also, this gets back to another question. A lot of nutrition experts, some of the best ones in the world, say there's only one diet that's the best in the world. Very low fat, whole food, plant-based, 100% vegan, organic. Okay, fine. But I'm asking a question. Should a cancer patient maybe even drop their protein intake more? From what I've read, I think they probably should. Now, where do you draw the line? I don't know. And another question comes up. There's lots of proteins in greens, but you know what? There's hardly any calories in greens. So even if your percent of protein is higher in greens, there's so many other nutrients, antioxidants, etc., nitric oxide, etc., precursors. And, the great Ruth Heidrich, PhD, who cured herself of metastatic cancer, she ate lots of greens. She would start her meal off with a big bowl of greens, she would say. And she's as sharp as it gets mentally, physically fit as it gets, rather extraordinary. Okay, so you can see the remaining questions here. And then you also say, is there a way out? How do I win? Well, maybe you should reduce beans if you got cancer to reduce your overall protein intake. And here's the other thing. The more I'm studying fruits, the more it's looking to me like fruits keep looking better and better. That guy, Michael Arnstein, that ultra-marathon runner, was a rather extraordinary guy, just like the picture of incredible health. And this book here was a rather impressive book. I'll talk about this in the future. Raw Can Cure Cancer. This was written by Janet Murray Wakelin, and she basically had metastatic breast cancer too, and she started eating tons and tons of fruits, also some veggies. I'll get more into the details in the future. She ran in a circle all around Australia, rather incredible. So that's my point. Does the diagnosis of cancer mean you're doomed to, incredibly aggressive surgery and chemotherapy? And sometimes that's the best thing to do, but the point I'm making is Ruth Heidrich and Janet Marie Wakelin, they went around running marathons. Okay, so that's a topic for a future time, but we still have the question here, and this is the one I really think has not been resolved yet, and I'm curious to see what T. Campbell has to say about it. I'm going to keep reading about it. I got to go back and read the Mitchell paper, but it's a rather fascinating question. Where do you want your protein intake? And if beans are so great, how can they be so great when they've got 25 to 30% protein and even more in the soy protein? Okay, how could soy be such a great food when I forget the exact percent in soy. I think it was like 38%. It's a lot of protein, more than the other beans even. So anyways, I'm going to come back to these questions, but I'm planting in your mind these key questions because I think that they're essential. And anyways, I hope that was interesting.